Hi guys, welcome back to a quick little update video on Omala. Thought I would talk a bit about what I've been doing the last week or last 2 weeks, and it's mainly been working on the generator engine that I got for her. So I thought in this video I would talk a bit about the electronics that I've been installing on this generator and how I plan to use the generator and how I want to install it in the engine room. So I would like to show a bit how I plan to lay out everything, also with the main engine and generator engine and the fuel tanks. And then I was hoping if some of you could give me some feedback on how I'm doing these things, because yeah, I'm just figuring it out as I go along, and I'm not a boat builder and I'm not an electrician, so any advice is welcome. But let me show you what I've been working on. So this is the generator engine for Omala. It's 15 kVA. Which means I can pull about 16 amp on 3-phase power from it. It's a brand new Italian make generator that I got from Marketplace. It was an unfinished generator project from a guy, and I got it quite cheap. Yeah, but it came with no electronics whatsoever, so the sensors were not hooked up, and there was no control. Generator controller, so that's what I've been working on now. Let me show you. So this is a cheap Chinese generator controller that I got donated by Michiel. Thank you very much for that. And I hooked it up so I can be sure that if something goes wrong with the oil pressure or water temperature or whatever, the engine will cut itself off. I do not plan to start this generator up in the wheelhouse of Omala. I want to start it in my engine room when I need it, and maybe have a kill switch close to the companionway that goes into the engine room so I can stop it in case I am outside of the boat. But the way that this controller works is that I need several sensor inputs. The little rabbit here is, it looks at engine speed. That's the only sensor I don't have hooked up yet. I'm waiting for that one from China. So that's this cable here. And that's basically an MPU speed sensor. So an inductive sensor that looks at the teeth of the flywheel. And therefore it gets pulses and it can figure out what speed it should run at. And I think this unit is supposed to run at 1400 or 1500 hertz. Generating 50 hertz 3-phase power. Then the next sensor looks at its oil pressure, of course, water temperature. I think if the battery power is too low, and this last one I'm not entirely sure. But yeah, anyway, so what I've had to hook up is that I hooked up a oil pressure sensor or water temperature. Then what else? Well, of course I had to hook up the alternator, starting solenoids, starter itself. Yeah, quite some sensors here and there. I have an exhaust sensor as well that I want to hook up to an analog gauge, so you can see how hot the exhaust is. It's a wet exhaust, which I'm really happy with. It will make the plumbing a bit easier for me on the boat. But what I made, I can show you on the backside actually. So it's that little box there. It just has some connectors on the side. So battery plus, crank speed, temperature. Yeah, you get it. It's from China, and I think it works okay. I haven't actually had it running completely with the engine because I don't have any fuel hooked up right now, but it can crank over. I also installed a little battery gauge, so it shows the voltage level of the battery. Then down here I have a button hooked up to a relay that does the glow plugs. You could do it via this unit as well, but I prefer to do it manually. And then, well, it turns on, and as you can also hear, I can crank it. And by doing that, you also actuate the starter solenoid. And I think about 30 seconds from now, or 40 seconds, it will disconnect this starter solenoid, because it will give an error here because the speed sensor is not hooked up. So the engine, by all this controller knows, could be running right now, but it doesn't get any speed input. And what I hooked up, when it gives this error, it means that this alarm will go off that I also hooked up. So I will have some sort of indication that the generator is malfunctioning or whatever. I also there it goes. Also made an override so I can turn it off. But as you can see here, there's a sensor error, and yeah, because it's not hooked up right now. So that's the very basic electronics. It was a bit of a learning curve to install all this wiring. It's a lot of playing around with solenoids, which is quite fun. Like for instance, the water temperature sensor is a normally closed sensor, where this one needs a normally open input. So I had to invert a signal with a little relay in there as well. Then there's 4 relays in here, one for the glow plugs, as I said. There is one for the starting solenoid to engage. Then there's one more solenoid to keep it engaged and disconnect the main coil, because there are 2 coils in there. And then the 4th solenoid is also the starter for the starter motor. And that one is hooked up in parallel with the holding coil, so the 2nd coil on this one. So it energizes, holds it, and then the starter also cranks over to start it. And when this one gives an alarm, first thing it does is that it drops that solenoid here, the big one. And that actuator is connected to, I think, both the governor and the fuel pump. So then it doesn't get any fuel and it cuts off. What else did I change to it? Well, the way this was hooked up, let me show you. I'm not entirely happy with that. The power from this one was hooked up, well, you had this box here and this one here, so you get single phase power and 3-phase power. Problem is there was no fuses hooked up whatsoever, which I think is a bit scary. So my plan is, well, I made a little cover plate for this, and also says power takeoff only after a fuse. My idea is that I connect a cable from this to a fuse box that you have on construction sites. More, yeah, something like this, but smaller, like a little portable one. Because I only plan to use the 3-phase power to run tools in my machine shop or in my machine room. And maybe when I do some welding on the deck or have salvage pumps. I don't actually want to have 3-phase power inside of Omala in the interior. I only use single-phase power for that. So, what do I want to say? Yeah, I'll have this hooked up to a little fuse box with some small outlets and some 16 amp fuses for each phase. And when I want to, so let's say I'm sailing with Omala at sea and I want to have power in my kitchen, I literally plug in my land power cable in the fuse box, the little fuse box I will have up here. So there can be no confusion on accidentally hooking up land power to land and running your generator as well. Of course, you can do that with fancy solenoids, but I don't have actually any money for that. And then this one, yeah, the 3-phase power will go on the small fuse box, and from there I can just plug in the tools, whatever I need. So I don't have any meters hooked up for measuring current on the coils. I have installed 3 small coils on each phase, so in the future I can hook up some gauges if I can find those cheaply. And then over here, one of my electronics friends said that the neutral and the ground from the generator, so the generator here goes in here, and then the neutral and the ground I should ground to my frame that gets welded on the boat. Only problem with this engine is that it's not really a marine engine. That means that it's not isolated. So the block is minus and you have a plus on the starter motor. My main engine has it different. I made that so that everything is isolated. The starter motor has a plus and minus. Even the alternator has a plus and minus. But here it's all connected. Good thing is it is on rubber mounts, so technically it is isolated, but it's still, yeah, there's some issues with grounding and doing it this way. But now the AC part is secured because that's grounded. The 12-volt system for actually running the engine, I'm just gonna leave as separate as possible. So I just have a small battery, 12-volt battery like this here, that I mount on a little battery box with a cutoff switch, and that will run this engine. It will not be connected to the rest of my main engine. So yeah, that's the generator engine. And I also finally decided on names for my engine. I think I'm gonna call them Laurel and Hardy after the comedian duo. So Laurel is the thin one, that's this. And my Perkins 6.354, my main engine that I built, will be called Hardy. I also can show you one of my other projects that I'm working on. And my plan is that this thing, which stands over here, will get mounted on top of my main engine. So my main engine will be, let's say over here in the engine room. I'll remove these two boxes and I'll have this lathe on top of it. Mainly because I need a lot of extra weight in the back of the boat and I can't fill up much more cement in there and beton. So I want to have something heavy in there. And I think it's really cool to have a lathe in your boat. As you can see, this one also needs 16 amp. So that will be in my engine room as well. This will be another video because it needs a little bit of maintenance. One of the gears broke off in the compound, so I need to machine a new wheel for that, or a new gear. Yeah. And now I thought I would show a little bit about how I plan to lay out my engine room. Which you can see on the whiteboard here. Let me sit down. So that's the bow, that's the stern of Omala, and these thick lines are still the bulkheads that are left. So I have my front peak, which is going to be the bedroom for Ike, for our son. This is going to be like a living room slash bedroom area, and then there's the whole floor on top of this that I haven't drawn. But the way you get into the engine room is by the companionway in the back of the boat. Then you enter this main room, which is the engine room. And then there's two storage rooms in the back, which is an old fuel tank. And the old day tanks are also still part of the engine room there. So my plan is in the front of the engine room will be my main tank, which is 900 liters of diesel. And I just need to paint it. I just finished rebuilding it. Across that I will mount Laurel, the generator. Then of course my main engine with the drive shaft or the propeller shaft this way. And then my day tank mounted in this corner here. So I will have a manual fuel pump. So I can pump from my main tank to my day tank. My day tank will be about 2 meters above both engines. So I actually won't really need a pre-pump or feed pump to feed the engines. Even though Hardy does have one, Laurel does not have a feed pump for diesel. Then I'll have walkways 3-way around the main engine, and I can actually stand on there. And the engine room is 210 tall, so I will still be able to stand without bending my head. And then my plan was to mount my lathe above Hardy, so with the drive shaft the same way as the main axis of the lathe. So I can actually walk around it and maybe have a little workbench over here as well. Then my battery bank in the old day tank and an air compressor in the other day tank. Yeah, so that was my plan to hook it up very crudely. And if you guys see any problems with the way I install this, please let me know. I'm not entirely sure if the lathe is going to be there or not. I hope it will fit. I think it does. Otherwise, instead of having the lathe on top of the engine, I will mount a wooden workbench on top of the engine. Of course, making sure that I have at least a meter space below the top of the engine and my workbench, so I can still do maintenance on the engine. Yeah, so that was a quick update video on this little generator engine. It's been quite fun. And I hope to do some more videos soon, but I need to find another camera because my camcorder broke. So now I'm filming it with a phone. See you.